such a system called also log. Another category of the system code is a file management, which you can, using such a system code, you can create a file. For example, fopen. So to create a file, you can use the fopen or delete the file, okay, remove, and open the file or close the file. You can then read the file with the various options. You can open the file with the read option, read only option, or sometimes you can open the file, read and write option. So it's a parameter value. Okay. The next category of such a system code is the device management. So you can, for example, the USB device or the input and output device. There are many other devices connected to the motherboard through the controller. So you can manage such a device using the system code. So mostly when you purchase or when you install the operating system, these system codes are provided. Then system programming means using the system code and interface, you can make the monitoring program or the device management the program. You can code your program, the system programming, that is called the system programming. And also you can use the system library for management, maintenance purpose, like the information maintenance. You can get the time or the, for example, VM status or the IO status and uptime. These are the information you can, the command for the information maintenance is frequently used by the system administrator. So system administrator, sometimes you want to use customized monitoring process or the monitoring the interface. At that time, using such a system code, you can make your own program. I prefer to use the actually the shell program for when I was the system administrator. So for example, have you ever used the Perl program language? Perl? You?
A little bit.
So when did you use? For what?
I can't talk about it.
So it can be used for something research. Also it can be used for the web programming. So you can use such a Perl. Actually the Perl was developed by system administrator, Unix system administrator. I forgot the name of him. So he was the system administrator at the time. He needed something, the nice, convenient shell programming for maintenance purpose. Okay, so Perl provide a very nice system at the function. You can by using that the function you can monitor the system. So it's good for system administration. Okay. Another popular shell programming used by the system administrator is AWK. So I'm not sure whether you heard about the AWK. Each letter stands for the author of that. So 3 guys developed this program. This one is good for handling the data. So when you work for the system administrator or database administrator, so you will get a lot of log data you need to check. Sometimes it's real time, or sometimes you need to check any log created the last night and so on. At that time, most of the log data is not like the relational database model. So it's just the log data is semi-structured. So when the system logs are created, probably some of the program in your operating system print out to the console or the standard out, standard error, something like that. By the way, what is the difference? Console, standard out, standard error, what are they actually?
Standard error doesn't have a buffer where standard out does.
Actually, what are they? First, it's the file attribute. when you create a file, it will be automatically created. The standard out is 1 and 0. Standard error is the one file description. The one you can specify. You can not the file. It's a process attribute. Okay. So you can use such a standard out, standard error, and the console. Console is the different one. Console is the master, the output. So it's used by it's directly connected to the your computer. Other thing is when you create a process, it's automatically created file descriptor. Okay. So you can in your program you can print. Okay. That means its output goes to the standard out, something like that. It's a file descriptor. Then you can redirect to the file. Then you can make the load data. At that time, you wanna make the very simple the format like the time and error message. But if you have the thousand or the 10,000 lines last night, it will be hard to search and manage. So at that time, AWK is very, very nice tool to handle such a log data. Also, system call provide the several system call library for communication. So create the delete the communication at the IPC, inter-process connectivity. So how can you communicate? How can the process communicate each other? As I little bit showed the last time, it can use semaphore, it can use the shared memory, it can use inter-process communication protocol, IPC. Okay, how can you create such a communication protocol using the system library given by your operating system? Okay. Also, you can send a list of the message where you can create something data structure sometime like the queue. Queue is a first in first out, so it will be fair. So you can send first you define the queue in your process. So who provides such a queue data structure? Your operating system already defined. So what is a queue? Then you can just call that queue, then send the data. Okay, then the other process can open that queue and get the data from such a queue. That is send and receive the message. Okay. Also, you can use the shared memory model. So you can create the bulletin board like the shared area to communicate each other. Also, there are nowadays the protection and security are very important. System core, there are system core that preserve such a protection and control access services and so on. Okay, so these are the example of the system library. Some incomplete released by the Windows based or the Linux based. You can see to create the processor in Windows API, it is a great process. While the in Unix environment is a fork and exec. But nowadays, many of the operating system provide the very getting simpler. So usually the fork and exec are paired, but nowadays they use the P fork, P create, process create. That's combine both the fork and exec systems. Okay. For the file management, so you can use open, read, write, close, but there's each the operating system family branch always. I'm not sure whether I put. Usually I hand out several years ago the history of the operating system. It's kind of family tree of the operating system. It's a BSD family tree and the system the operating system and so on. Depending on such a branch of the operating system, they use a little slightly different the naming. So these are the general. For example, the POSIX, they use the P something, P something. Windows, they use the more the natural language style, the naming. Okay. And also, many of these system core system library are used for command. Okay, so as an application. For example, you can directly use the chmod to change the permission of the file. Okay, change mode. Okay, UMask and the chown, many of them are actually the application. How do you know whether this is a function system call or whether this is application? Always in Unix or Linux environment, you can use the command. What? You can use the man. Command. So, for example, if you want to know about the chmod, the man chmod, it will show whether this one is implemented as a system library or the application or command and so on. So man means menu. So that is the first command that you need to know when you learn the Linux and the Unix environment. This is an example of the C library, how it works using the system core. So this is a user mode, user source code, and in your source code you want to use the print. Okay, the library, C library. That is a C library. That's not the operating system code. You'd like to print. There's something data greeting. That message at the time you cannot. Your process does not have any permission to create it. Any way to print out such a greeting to the standard out, okay? You should have the permission to use the system out. How can you do that? You can change the mode into the kernel mode, and your kernel will take over some parameter that is a system out, the destination and the message, and you can use the system code. Okay, then you can write the message to the destination standard out, then it will return it's okay. Then the return value 0 will be returned to the user who execute your program. So that is the this diagram show how the system code is working with the standard C library. This is an example of the MS-DOS. Actually, as I said, MS-DOS is another the operating system. Actually, that caused a huge problem on top of the Windows 95 or 30.1. There's another operating system, DOS program. So there are two the operating system in one system that caused a huge problem. That is the reason the Windows 3.1 or the 95 is one of the worst ones. So that is another reason. From the Windows, I think that at the time the Microsoft has the Windows NT. It's the first server, okay, to make the difference from the such a unusual architecture of the operating system. Finally, they combined from the Windows 2000, right? Combine the personal operating system and the Windows NT to the Windows 2000. So MS-DOS is used for the single tasking. So when I learned the operating system first time, I learned MS-DOS first. So like the copy command, the CP, move, MV, and what else? delete, right? And dir, there is a list of the file. So these are the commands provided by MS-DOS, not Windows 3.1. Okay? Because it was easy to build a new operating system, just build the bar, the adapt, to MS-DOS, the DOS program, then make the Microsoft DOS, then include in the Windows. Windows 3.1 is basically focused on Windows, the interface. Okay? Not just Windows, but mostly the not just the interface, but the mostly such a Windows, the graphical user interface. However, in the PSD Berkeley branch, the Unix system, it used this is the memory. Okay, you are lower to higher the address. First, the kernel will be located in the lowest part of your memory. Then, whenever process is created, it will reserve some area, like the process B, process C, process D. Sometimes there is a free memory area, and also interpreter is also process, right? Interpreter is a compiler to understand the input of the user, so you should have such an interpreter. Yeah. Do you see the difference between the MS-DOS and this FreeBSD style operating system? The MS-DOS has only one process because it's a single task. It's a personal use. But the Unix, the operating system, the BSD, it has multitasking. You can use the memory for multiple processors. Then what is the system program? Using that, the system library, you can implement the application for file manipulation, whatever, and so on. So that is nowadays I have a friend who works in the company in the San Jose. It's very hard nowadays for entry level who knows system program. So also the experienced guy, not easy to find it. Even though company is not for the operating system, they need something such a program. Nowadays the application level program, they need to, there's no clear boundary. Which one is the system programming, which one is the application program. Think about the virtual machine. Virtual machine definitely should know how to handle the computer resource and convert into the other virtual machine. So for example, if you implement a virtual machine on top of the Windows, that virtual machine player or the program application should be able to handle, coordinate the computer resource through the using Windows. Then if you build the virtual machine for the Linux, okay, so you need to support such a thing in terms of the hardware. The system programming is another important a kind of the system programming. So it's a similar category of the system library. So you can create a file management status information. So second project, eventually you are going to do the system programming for file management. You are going to implement file system, portable file system. Okay. It can be Windows, it can be based on Windows, it can be based on Linux, so it doesn't matter. But on top of the existing file system, you are going to create a new file system. The requirement is given, but you can add your own requirement for better quality of your project. Okay. Later, when we discuss about the file management, we will talk more about it. And also the system programming support the programming level also. So programming languages support like the assembly language definitely. The assembly language is the only language that computer machine can understand. However, directly coding the assembly language is not easy. So we need higher level, the language that close to the human, the language, like the C program, .NET program, and the Java program. Even though if you have the reasonable logical thinking, I think then, even though you do not know the details, the syntax of each function, you can understand what's going on from the source code, right? But when you see the assembly code, not easy to understand what's going on, what happened. So compiler is going to map the high level, the source code into the assembly code. That can be supported by also the system library. So compiler is also application program. So you need to implement using the program language. And also, when you execute the program, you can create the process. That means you can load such a program and execute to the memory that can be done basically done by system library. Okay. Communication. What kind of the system programs that we have based on using such a system library? We can create the program. So we can say the basically application program or the system program. What kind of the system program is the background service. Background service is quite similar as a services that you can find from the task manager on Windows-based operating system. Okay, it's when you start up your operating system, Windows system, such a if you first when you install the operating system, a Windows operating system, Windows provide the default service. Okay, so some of them are for the monitoring, some of them are for the management, or some of them are for communication, and so on. So such a service is called the background services. And what about the Unix? Unix is also same. Unix, when you start an operating system, Linux or Unix operating system, it will start the default program. From where it is set, you can change it, the Windows, the service in the ns config or the task manager. You can change it. You can enable or disable. You can the close, something like that. And the Unix or Windows, Unix, Linux. So you can use init.d directory. There are 5 that should be executed when your operating system, Linux system, is starting up. There are different levels of actually starting up, just like the Windows. Windows has something different mode, right? If you click the F8, there are different modes for starting up, the safe mode or the debugging mode or whatever. Similar, Unix has the different mode that is the determine which process will be started. It's in the RC point D. I cannot remember it. Anyway, the init.d, the etc, and the etc init.d. The files in the init.d will be executed. We will see some example when we install the not this person. I got confused. The NoSQL database. So many of them are daemon program, which means, as I explained, the daemon program is their parent process ID is not the parent's one. It's going to be one or the kernel. So then it will be running until the system is done. Application, on the other hand, the application program will be run by, executed by the user. Your level, it has a parent process ID. Okay? So when you start up mostly the operating system, it will not be started. The user need to start it. But after you sometimes your application program, for example, I'd like to check my stock price every 5 minutes. So I create that program using some communication network programming, or you can use the Ruby or the Perl program to request a website and analyze get the stock price. So you can register to the system programming background service. You can need that kind of program. So if you want to know more about such a system programming, you can go to such a link, or you can find more information from the internet. So what if somebody asks me to design the operating system? It's rarely happen. However, nowadays operating system is not only for the Windows. It's not only for the iOS. sometimes you need embedded operating system for your device. So if you get a job in a small company that developed something healthcare, the device, okay, even that device need the operating system. It's an embedded operating system. So you need to, especially for computer science, the major, that's the major job to develop such an operating system design and implementation. So how can we design nowadays the operating system? There are two parts you need to consider. One is the system. Due to the nature of the operating system, what is operating system? It's in between user, human user, and computer, machine. So you need to see the system part. Also, you need to see the user part. Sometimes they are conflict. Their objectives are conflict, so you need to adjust such a thing in your design of the operating system. User goal, as you can guess, is convenient, always convenient. But if your operating system is too much convenient, it's nice interface, something the smoothly move and the fancy nice color, but your system will be slower, right? Because you use a lot of research for fancy nice design. But for example, my daughter, she loves the pink color and design the desktop, everything, and she complained why my computer is getting slow. So actually, when she goes to high school, the high school provide the laptop. So my son, Nicholas, he is the fourth grade. He take over my daughter's the old laptop. Then I actually reinstalled the operating system. Then my daughter, she surprised. It's so fast because I disable everything, desktop and the animation, and I put very basic stuff. And that is the Windows 7. It works very well, even though that is the 2010 model, 2009, but it works well. So my son Nicholas he is satisfied, but she complained, why? It's the same computer, but it was very slow. So it's the same thing. So you need to juggle the user goal and system goal, and definitely the system is simple and easy to manage, but also it's flexible and reliable, something like that. Okay? So this is the one strategy to design the operating system. Okay. Policy. Actually, frankly speaking, I never designed the operating system, so I learned from the textbook. But here, so first you need to decide the policy. What is the purpose of what you are going to allow in your operating system? Okay, is it free to use all the resources? If that is your policy, you need to find. But if you allow the whole process can access without the limitation all the research, provide some, there might be a conflict with the problem. So you need to decide the policy of your operating system. As I mentioned in the first class of this semester, if you have the unlimited resource, we don't have to worry about such a thing. We don't have to learn such a complicated operating system algorithm, whatever, because we have the limited resource. We need to coordinate such a resource for multiple users. Okay, so at that time we need the policy. Then how can we implement such a policy? So at that time you need to find the mechanism is algorithm. So first in, first come, always, or priority based, was something ABC algorithm, error listen to use algorithm. So you need to find such a mechanism, then implement it. Okay. The time, I agree, the most important part is software engineering. Okay, this is not the developing operating system cannot be done by a lot. I know sometimes when genius guys they hack the existing operating system, make the exactly same one. So, but now even nowadays, hacker group is a kind of group. They work together. they communicate. So software engineering definitely very important. Then after you make the policy and direction or the algorithm, how can you implement? Believe it or not, C and C++ is the mostly used programming language for system, including operating system. Then some part will be assembly language directly. That's the same story in the database management system. So C and C++, I still believe the most important programming language that you need to understand. I learned the C language 25 years ago. It's already 26 years ago. At that time, it was not my major. I just took the as an elective for the, it's not computer something. I don't, some machine, whatever. Then they taught the C language at the time. C language and Fortran. So I learned the Fortran long time. October also, one more language. So I learned the 3 languages in one class for non-computer science. My major was mathematics. So it was very tough, but it was interesting. But most difficult part when I start to learn the C program is what? Pointer. To understand the pointer, you need to understand data structure of the memory. Okay. So because of that, sometimes many of the students start from the learning language, okay, without understanding the data structure. So I still believe the most important thing in CS 101, 102, you should learn the data structure first. Okay? Then the other, if you can understand the data structure, memory structure, and the file structure is relatively easy. Okay, so especially for the memory structure, then I think the understanding process means the program means program language. So it will be easier to understand such. But many students, almost 90% of the students give up when you start to learn the pointer. That's true. And what other thing? What is the other difficult things when you learn the C language? Handling, it's the same thing, string. There is no given the library to handle the string, so you need to implement by yourself in the C language. Anyway, so C language is used for, then also embedded operating system, embedded program. C and C++ are very popular nowadays. Some of the shell program languages like the Python and Perl and such shell program language are used for such as system program. What if I do not have the new device? Think about Android. So how can we implement the operating system? We have emulation that simulate the real